Now let's talk about graphing logarithmic functions. Let's go over the four basic shapes. So let's say if you have log x, where x and y are both positive, kind of like what we did in the last lesson. In this case, the graph is going to travel towards quadrant 1. Logarithmic functions are basically the inverse of an exponential function. Exponential functions contain a horizontal asymptote. Logarithmic functions contain a vertical asymptote. Exponential functions, they increase at an increasing rate. Logarithmic functions, they increase at a decreasing rate. So let's say if we were to put 2 to the x and log to the x on the same graph. This is the basic curve of 2 to the x. And the graph log base 2 to the x looks like this. I'm going to highlight it in blue. These two functions are inverse functions. An inverse function reflects across the line y equals 0 with its counterpart. So let's say if this is f, this is the inverse of f. They reflect about the line y equals x. Now what is the graph of log of negative x? This graph is going to reflect across the y-axis. So it's going to go towards quadrant 2. In quadrant 2, x is negative and y is positive. Now the next shape you need to be familiar with is this one. Let's say if we have negative log positive x. If the negative is in front, instead of reflecting over the y-axis, it's going to reflect over the x-axis. So it's going to travel towards quadrant 3. In quadrant 3, x is positive, but y is negative. And the last one, where y and x are both negative, this is going to occur in quadrant 3. So this reflects relative to the origin. It reflects across the origin relative to the original function. So those are the four basic logarithmic functions that you need to know, using transformations, of course. So now let's work on some examples. Let's graph log base 2 of x. So the first thing you want to do is you want to set x equal to three things. You want to set it equal to 0. This is going to be the vertical asymptote. Next, you want to set it equal to 1 and also whatever the base is. The base is this number. So you want to set it equal to 2. Next, make a table with the 2 points, 1 and 2. Log of 1 is always 0. Now log base 2 of 2, if these two numbers are the same, it's going to be equal to 1. So now we can graph it. So the vertical asymptote is x equals 0, which is basically the y-axis. And now we have the points 1, 0, which is the x-intercept, and 2, 1. So we're going to start from the y-axis and follow those 2 points. And that's how you graph it. Now for exponential functions, the domain was all real numbers. For logarithmic functions, the range is all real numbers. Notice that the lowest y value is negative infinity and the highest is infinity. This function will continue to increase forever. So the range is from negative infinity to infinity. The range of exponential functions was restricted. The domain for logarithmic functions is also restricted. The lowest x value is 0 and the highest is infinity. So the domain is going to be from 0 to infinity. Another way you could find the domain is take the inside and set it greater than 0. X is greater than 0 from 0 to infinity, not including 0 because 0 is the vertical asymptote. Here's another one that you could try. Log base 3 of x minus 1 plus 2. Feel free to pause the video and go ahead and graph it. So let's take the inside part, x minus 1, and let's set it equal to 3 things. 0, 1, and whatever the base is equal to. In this case, the base is 3. And find the value of x. For the first one, this is going to give us the vertical asymptote. So x equal 1, that's the vertical asymptote. The next one will have 2, and then 3 plus 1 is 4. So the 2 points that we're going to plug in contain the x values 2 and 4. And x equals 1, just keep that in mind, this is the vertical asymptote. Now let's find the y values. What is y when x is 2? So log base 3, 2 minus 1 plus 2. 2 minus 1 is basically 1. Log of 1 is always 0. So this is 0 plus 2, which is 2. Now what is the y value when x is 4? So this is going to be 4 minus 1. 4 minus 1 is 3. Log base 3 of 3, because the numbers are the same, it's going to be 1. And 1 plus 2 is 3. So now we have everything that we need in order to graph it. So let's go ahead and do that now. So first, let's plot the vertical asymptote, which is at x equals 1. So next, we have the point 2, 2, which is not there, but here. And then we have the point 4, 3, which is there. So the graph starts from the vertical asymptote, and then it increases towards those points. And so that's how you can plot it. Now go ahead and identify the domain and the range for this graph. The lowest y value is negative infinity, and the highest is infinity. So the range is always going to be all real numbers, negative infinity to infinity. Now let's talk about the domain. The lowest x value, in this case, is the vertical asymptote, it's 1. The highest is positive infinity. So it's going to be from 1 to infinity. And so that's the domain for this function. Now let's try one more example. 3 minus log base 4, 5 minus x. So let's set 5 minus x equal to 3 things. 0, 1, and whatever the base is. In this case, the base is 4. So x is equal to 5, that's the vertical asymptote. 5 minus 4 is 1, so x is 4. And 5 minus 1 is 4, so x is 1. The two x values that we're going to need are 1 and 4. And the vertical asymptote is x equals 5. Now let's fill in the table. So let's replace x with 1. 5 minus 1 is 4. Log base 4 of 4, because the numbers are the same, is equal to 1. So this is going to be 3 minus 1, which is 2. Now let's find the next point. Five minus 4 is 1. And log of 1, regardless of what the base is always equal to 0. 3 minus 0 is 3. So all we need is 2 points and the asymptote, Once we have that, we can go ahead and graph it. So let's begin by plotting the vertical asymptote, which is at x equals 5. Now we have the point 1, 2, and also 4, 3. So the graph is going to start from the vertical asymptote, and then it's going to follow these 2 points. Let's see if I can draw a better graph. And I missed it again. One more time. So it's going to look something like that. So notice that the graph is going towards quadrant 3. Eventually it's going to get towards quadrant 3, but it's going to take a while before it gets there. You can look at the signs in front of x and y to determine that. So notice that the sign in front of x is negative, which means that the graph is going to go towards the left. And the sign in front of the log is negative, which is associated with y. If y is negative, that means that it's going to go down. So relative to this point, it's traveling towards quadrant 3. So just by looking at the signs, you can determine what direction it's going to go. If you don't want to do that, the points will tell you where to go. Always start from the vertical asymptote and follow the 2 points, and you're going to get it right, as long as you start from the asymptote. You can't graph it like this. It's just, this is not going to work. The only way to graph it is to start from the asymptote and follow the 2 points.